Okay, in this class we're going to talk about green computing, which could also be called sustainable computing or green IT. So what is green computing? Green computing is the term used to denote the efficient resources in computing. We also call it green IT. And it's where organizations adopt a policy of ensuring the setup and operations of IT produces a minimal carbon footprint. Some of the key issues: energy efficiency, environmentally friendly computer technologies, and it's the study and practice of designing, manufacturing, using, and disposing of computers. So a quick history, a short and not so glorious history of green computing. The term green computing or green IT was coined shortly after the Energy Star program began in 1992. One of the first sightings of green computing was the now ubiquitous sleep mode in computer monitors, which we're all now very familiar with. Shortly thereafter, corporations began employing concepts such as thin client solutions, where a desktop computer is essentially a computer program that depends heavily on a networked server to fulfill its computing roles, basically what we refer to as dumb terminals. And also you have concepts such as energy and cost accounting, where it's basically a system used in energy management systems where measuring and analyzing energy consumption is done to improve energy efficiency within an organization. We also have virtualization practices, which we've talked a lot about with respect to cloud computing. You have e-waste, where you have proper recycling of old computer equipment, CRT monitors, servers, etc. And of course, the notion of cloud computing, contributes to our understanding of green computing as well, because it simply removes the physical footprint of things you would have to dispose of, properly cool with respect to data centers, and just that physical footprint in general. It removes our notion of having that type of physical presence of computing in an organization. So cloud computing definitely contributes to that, and that's probably the most modern incarnation of green computing that we see in information systems. So what are some core objectives of a green computing strategy? Well, I would contend one is minimizing energy consumption, finding ways to harness green energy or renewable power, reducing paper and other one-time consumables, minimizing equipment disposal requirements, and then reducing the requirements for the users of a system, such as travel, printing, etc. So what are some of the reasons for adopting green solutions? Well, the largest one is to reduce energy costs. Energy costs are increasingly going up. Our electricity bills have gotten higher, our resources have gotten more scant, finding ways to reduce energy costs is a big reason for adopting a green strategy for your organization. Another one is extending the useful life of hardware. The more we can get out of our hardware, the less we have to worry about disposing it, buying new hardware, etc. Reducing IT maintenance activities. We want to be able to not have to employ massive amounts of people to have to worry about the physical presence of hardware in your organization. Saving money through waste disposal of non-toxic hardware. Also, it improves your corporate image. If you are adopting a green strategy, you can market that. One of the big things, for example, that Apple marketed was the fact that they're trying to get away from using rare earth materials, where much of it's mined in China. They're trying to get away from using a lot of those also to lower the cost of things like the iPhone, and to also get away from potentially bad practices of earth mining. Another one is reducing carbon emissions, reducing energy consumption. Also, freeing up space in your data centers is a huge reason to adopt a green solution. So these are just kind of an overview of a survey that I found in Computer Weekly of why people adopt green solutions. So it's pretty interesting. So, to continue along that path, why go green? Well, you can positively impact climate change. There's potential cost savings. You can use power from reliable sources. And, it just creates the idea of low impact computing. So let's, examine some of these thoughts in more detail. With respect to climate change, research has shown that carbon, CO2 emissions, carbon dioxide, and other emissions are causing, serious global environment and environmental damage. So, getting away from that, finding ways to, use different energy sources and things like that. Cost savings. Green computing can lead to significant cost savings over time. Reductions in costs can come from the reducing the amount of servers you have, the amount of cooling you have to do for those servers, the lighting for data centers, things like that. If you've ever gone into a data center, it's really cold in there. Because computers generate so much heat, they're really having to keep, you really have to spend a lot of money on cooling costs. There's another natural property of just elements that go into computing, and that's that electrons actually flow better in the cold. So that's why data centers are also cool, because it can actually help with performance. The cooler you have these things. So if you probably haven't seen this, but there's been a lot of articles and talk about having things like floating data centers where the ocean, where the cold, our nice cold Pacific Ocean can be used to cool the data center naturally, and then even having data centers on the North Slope of Alaska. So another reason to why go green is the reliability of power. The world's energy supply is declining or flat depending on who you listen to, and so over time, renewable energy sources can stand to be more reliable than traditional energy sources that we have. These things are changing. The way we acquire energy is changing. If you ever go down, towards the Bishop area, and as you get to kind of central and southern California, into the southern Sierras, they're starting to install huge solar power plants out in that area. And just recently, that area went online, so that's there to power, I think, a lot of the southern Central Valley in that area. And also, another reason to why go green is computing. With massive amounts of data and data processing in modern software applications, these data centers are going to run out of space and power more quickly. Increasingly, like we've talked about, we are trying to harvest and mine more, space, inconsiderate types of data, like high definition video. For YouTube, for example, now I can record this lecture, for example, as a high definition video. I have no need to because it's just audio and slides. But if it was high quality video that I was taking and I wanted to upload that, there's now a way to do that. So video is becoming more and more clear, and crisp, which makes the amount of bits that go into storing that video ever more increasing. So some approaches to green computing. Well, the first one we've talked about, of course, is virtualization, the process of running two or more computer systems on a single set of physical hardware. But you already know that. We've talked a ton about this stuff. But virtualization is one of the biggest ways that people go about their green computing strategy. Another approach to green computing is power management and supply. So power management, for example, there's ACPI, the Advanced Configuration and Power Interfaces, and power interface devices that allow an operating system to directly control the power of its underlying hardware. So this prolongs battery life, reduces cooling requirements, reduces noise as a consequence of that, or a benefit of that, reduces the operating costs for energy and cooling. And where this is configurable many times is in your BIOS, your basic input-output system That's usually on PCs. You have a BIOS. Macs work differently in the way you're able to do that. So a lot of those things are available in your simple power management settings. You don't have this necessarily in your BIOS. But in a PC, when you're booting up a computer, your BIOS, your basic input-output system, is the thing that starts your operating system. And there's a lot of ACPI settings in there that you can actually configure. So some more approaches to green computing. Well, first let's talk about power supply. Also, I forgot the second bullet here. For example, I'll give an example of what it means with respect to power supply. The Green Grid. This is a nonprofit industry consortium of end users, policymakers, technology providers, architects, etc., and even the utility companies that are collaborating to improve the resource efficiency of data centers. So people still need data centers, but there's a consortium of that espouses the best practices for running a data center. So some more approaches to green computing. Upgrading displays, that's a huge one. So displays take up the most power in your normal conventional desktop computer. So change the type of display. Most of us are using LCD or LED, but you want to get rid of those old CRT monitors. Also, and replace them with an LED monitor. Light emitting diodes is what LED stands for. And you want to use an LED monitor because even the LCD monitors, some of those flat screens that might be a little older, they still use a cold CRT monitor for their display. So they still consume a lot of power. So LED is the way to go. And over time there'll be something that's better than LEDs, but right now that's the way to go. And most modern laptops are using LEDs these days, especially because battery life is a huge issue in laptops, right? So you want to have the best battery life possible, so you want to be using the lowest power consuming display that you have. Some other approaches to green computing is materials recycling. Properly dispose of computers by taking them to a certified electronic recycler. They'll find other uses for the materials, such as charity donation, etc. Or they'll properly dismantle the system in a manner that allows for safe extraction of the constituent materials for use in other products. So this is especially true with respect to CRT monitors because they've got a lot of very harmful materials to the environment that you need to get rid of. And so there's a lot of pros and cons to e-waste, and there's a lot of controversy around e-waste recycling and who's doing the recycling, where things go. And in class, we'll show this video. If you want to watch it, you can. It's from 60 Minutes, and it's really, really compelling. I had a student last semester actually show me, send me this video. It was actually just in the middle of class. She just said, "Hey, we saw that in one of my other classes, I saw this really interesting video on e-waste. You might be interested." So I took a look at it for a second. I stopped the class and just decided that we should just watch this right now because it was really compelling, and we'll watch it in class. So some other approaches to green computing is telecommuting, right? Like telecommuting has been shown to significantly reduce carbon emissions. As employers are not traveling to work every day, it also increases worker satisfaction because you don't have to get up and go to work every day. It's kind of nice sometimes. It even shown to increase profit margins. Employees are more productive because they can do the stuff that they need to do without having to report it to their boss, take time off, etc. In IT, especially in things like software development, telecommuting and working in virtual teams is a very common practice. So, some paths to green computing, how to get there. First is, green use, intelligent use of energy and information systems. Green disposal, like we've talked about, reduction of waste through cloud computing, reuse, and refurbishment of computing equipment. Green design, efficient design of data centers and workstations. And I would also say that the efficient design of software is a big part of that as well. Green manufacturing, the informed purchasing of components is, another way to do it. Make sure that you're not purchasing computers that use materials that are harmful to the environment. Do some inspection into what you're purchasing and making sure that those manufacturers have good green computing practices. So now let's show some interesting statistics as to why this actually makes a difference. Here's one. Data centers produce 0.3% of the world's CO2 emissions. Now, that may not seem a lot, but when you take into account that that the average server has roughly the same carbon footprint as an SUV doing 15 miles per gallon, well, that kind of changes, the game a little bit. So 0.3 is actually a lot when you think about all the different ways that there's CO2 emissions. Let's fast forward to the next slide that tells us something. So another interesting statistic is that data center energy use in 2005 was 152 billion kilowatts per hour, or kilowatt hours. So in other words, what this means is that 1.2% of USA energy use is consumed by data centers. Now that's a lot, because there's a lot of different ways that we consume energy, and considering that that's taking 1.2% of energy use, that really shows that data centers have a huge impact on our energy consumption. So this corresponds with 0.8% of the world energy use. So when you think about all the different ways that we consume energy, such as the presentation I'm doing now, for example, and the fact that my laptop's plugged in and my light's on, and I had my coffee to get going, things like that. That's a lot. For just data centers, when you consider all the different ways that we're consuming energy as the human race. So what can we do about this? We've explored this a bunch. Let's talk a little bit more about what that means, from a statistical sense. So virtualization, on average, 32% of servers in a data center run around 47% utilization. So what that means is that they're only running at less than half of their capacity. So companies can achieve a near 65% reduction in server count just through virtualization. With respect to power management, PCs with a screensaver still use over 100 watts of power. That's a lot, compared with 10 watts in sleep mode. So companies can save between $25 to $75 per PC per year on power bills by powering down machines not in use. So make sure you power those things down. So electricity, and then the other statistic here is that electricity is nearly 20% of the total cost of a server over its lifetime. So that's a fascinating statistic. You buy a server, those are your costs. You upgrade it, you buy new operating system software for it, you do all these things that contribute to your TCO, your total cost of ownership. Electricity is 1/5, 20% of the total cost of ownership over the entire lifetime of that server. That's fascinating. Some other stuff about what can we do. Virtualization, right? Or, excuse me, I forgot to talk about the last bullet point. Power supply. So increasingly, if you work in a large organization, you have the option as to what type of power source you want to use. For example, I'll give an extreme example. Google, in Mountain View has a lot of green area behind its campus, and so instead of hiring landscapers to come in and landscape and consume all sorts of energy resources, they have goats. They literally have goats that go out and tame the grass, because goats love to eat grass. So goats are their renewable energy source, if you will. But you also, for powering something like a data center, you can install solar panels. Find ways to harness wind or hydroelectric power depending on where you're located, where you have that data center installed. Large companies, like Microsoft, Google, eBay, they have data centers that are in very remote places, so they have the option to install renewable energy sources. So more about what we can do. Recycling, from a statistical sense. 1 million tons of electronic equipment become obsolete each year. To make one desktop computer, it takes 240 kilograms of fossil fuels, 22 grams of chemicals, and over 1,500 kilograms of water. That's a lot. Another option about what we can do from a statistical sense is if all commuters work from home 1 day a year, an average of 5.85 billion fewer gallons would be used each year. We can also reduce paper. The average worker goes through 10,000 sheets of paper per year. So the pros and cons about all this, and kind of concluding this presentation on green computing. Green IT is as much about people and institutions as it is about technology. What we've shown from how we can design green computing, the statistics on what we consume, is that it boils down to human behavior and institutions, which are the conglomerate of human behavior. It's people act, in a micro sense, they act individually, and then they also act as a group. So green IT is as much about people and institutions as it is about technology. Also, it can be energy saving, environmentally friendly, and cost effective, of course, but there's pros and cons to doing that. It can help companies save money year over year, and it can even be a tax write-off. However, green computing can also have high startup costs. You have to, potentially buy servers that might be more expensive to realize its, espoused benefits. And some options, such as renewable energy sources, are not readily available. You can also sacrifice performance per battery life. So computers have to run at capacity to get optimum performance, or near capacity to get optimum performance, which can significantly sacrifice the battery life you have. And so it's not for all types of businesses, but you as potentially one day a decision maker as it relates to technology or software applications, things like that, have to examine whether or not, you have to examine what your carbon footprint will be. So it's not for all types of businesses, but it's something to inspect and something to think about, especially if you're looking at if what you're doing has any impact on the image of the organization. So that's all I have. It's a shorter presentation this week. So until next time, I think we're not this week, but the following week we're coming up on spring break pretty soon. So I think we have one more lecture, and then we'll have spring break. So until next time, hope you enjoyed the presentation. Class will be fun. We have a bunch of videos we're gonna watch during the presentation that relate to green and sustainable computing, and of course the e-waste one we talked about. And we have a case study. So make sure you read the case study, and I will see you this week.